In this video, we're going to go over the Lab 4 calculations and for energy expenditure, substrate utilization, and mechanical efficiency. On my sheet here, I have my Cycle Ergometer worksheet, or data that was collected. You may have the treadmill one pulled up. If you do, make sure you enter work rate. In here, it will just display 0. Make sure you enter the correct work rates in for your subject, though, as we will not get comparable values or anything like that if we don't put that in. We'll be using that work rate later for specifically mechanical efficiency calculations. So one thing that I did before starting was I typed in this person's VO2 max. Here I've typed it in for me on G11. You don't have to do G11 yourself, but as long as it's on here, that's good. Again, you can use the same one, but don't have to. Just know where it is. And on my left here, I have our worksheet pulled up, and you can see the tables. We have everything that's output by the Metabolic Cart up to RER. We are going to do gross energy expenditure, calorific value, exact energy expenditure, fats, and carbs. And then we'll also do relative to VO2 max or percent of VO2 max and mechanical efficiency. So let's get our table on the right set up to do just that. Let's do gross energy expenditure. That's in kcals per minute. And then calorific value. And that'll be in kcals per liter of O2. Then we have exact energy expenditure. That's in kcals per minute. And then I'm going to merge these because we're going to have two columns for fat. Just easier to read if they're together. Fats, carbs. And we have percent kcals per minute. So it's on here as kcals because technically that's a minute measurement, so to speak. So, we're splitting hairs. It's the same thing. All right. Then we have our last ones, which we have to go down below for, which are relative to VO2 max. That's in percent. And lastly, mechanical efficiency. Now you don't have to do this yourself. I'm just going to merge the cells above. Call this calculations. And bold that. Just, you don't have to, again, it's just for posterity knowing, hey, this is what I have to do. So we're going to do all these calculations, and if you haven't already, pull up the PowerPoint, and we're going to go to the statistics section. All right, so all of these data points that were put out by the Metabolic Cart, they all have about 15 digits in them, not decimals, but digits. So we don't need to always see all of that. I just minimized them. You can highlight them like so, and you can say, okay, display more or less. It doesn't get rid of them permanently. It just hides them and makes it a little bit more easy on the viewing is the main thing. We always want to keep everything until our very last calculations or anything like that anyway. So without that out of the way, we can start working our way down here. If you had entered values, you should have at most or at best 3 decimal places viewing for RER. That's the minimum requirement for it to get things that will work out appropriately. So without further ado, let's start the gross energy expenditure calculations. So equals, to start one of our Excel functions, 0.2 VO2, multiply by 5. That's easy enough. We can double click this, or if you so choose, you can drag them down. It always goes down to where the last number is, and it will stop automatically if we do that, so it's not continuing all the way down here. It's nice. And next we have calorific value. Now this is one that if I didn't tell you or if you didn't pay attention, it could be a little bit tricky. You might get some weird values for. But thankfully we're doing this video, so this will make it easy. One thing with this is it has a set max and a set minimum value, and that's what we're going to code in here when we're doing this. So to do it, we're going to type if, an if function. So if this is true, it's going to check something. If RER is less than 0.707, we're going to have it default to the minimum calorific value, which is 4.6862. That's the minimum calorific value for fats, utilizing all fats. We know that. And then, so that's if it's true. So if it's false, we want it to do something else. If it's false, check if RER is greater than 1. And if it's greater than 1, we're going to have it default to what it would be at 1, which is 5.0468. Cool. And if that is false, it'll actually carry out the formula. So we'll point again to RER times 1.232 plus 3.815. Then we have to put in 2 parentheses, close one if, then close the other. And for me, this is easy to check because this number is 0.707 is less than, 0.702 is less than 0.707. That's easy to check that, okay, it defaulted to the minimum value. Easy enough. So double click that. We can see it's increasing as we go down. Cool. Now we'll do exact energy expenditure. So equals 2. We're going to point to VO2 again and multiply by calorific value. The difference between gross energy expenditure and exact energy expenditure is exact energy expenditure, we're actually calculating what that calorific value is. For gross, we're just assuming it's 5. We're just assuming it's 5, and actually you can see these are all below 5. So the number would be a little off in the long run, so to speak. We'd be off. But one other thing we also get with exact energy expenditure is the percent of fats and percent of carbs. So to do that, we'll need that calorific value equals, on here we have a bracket and a parenthesis. The bracket is just in Excel going to be another parenthesis. It's easier to see where these are delineated though on here, so that's why we have it written as such on the PowerPoint page. So with this, we'll type in 5.0468. That's just the top number it could possibly be, minus the calorific value, the current one, divided by 0.3606. And that 0.3606 is actually the difference between the top calorific value and the bottom one. So 5.0468 and that number minus 4.6862. You get that. It's just easier to put that in rather than doing the subtraction each time. So, and then we lastly we multiply by 100, and we get, for me, I should get 100%. We're using 100% fats at that minute. All right, so equals 2. For kcals per minute, we're going to do exact energy expenditure, multiply by percent, divide by 100, and 100% divided by 100 is just 1. So it's the exact same number, which is exactly what I should get here. For me. Your numbers may vary. Lastly for this, we're going to do the percent carbohydrates or carbs. So equals 2 parentheses again, point to the calorific value this time first, minus 4.6862, close parenthesis, and then we divide by 0.3606, close parenthesis, times 100. And in this case, since I know what that calorific value is, 4.6862 minus 4.6862. That's 0 up top. So that's already going to be 0 divided by any number is 0. Any other number than 0, of course. But still, we get 0. And lastly, we're multiplying by 0 here. Exact energy expenditure times 0, divide by 100. Just for posterity. I want to do it because now when I do this, it'll automatically populate. All right. Sweet. So, what's some interesting things we can see here? So at the start, I was at 100%, or this person was at 100%. And as they were increasing their work rate in watts, they were shifting a little bit away, more towards middle of the road with fats and more towards carbs, which is what we expect. So we're seeing that. We can always check, do these kcals per minute add up? 10.6131, yep. 10.6131, yep. Cool. Easy check. All right, so that would finish off for this person, the cycle ergometer table. Let's also do the relative to VO2 max. So the relative to VO2 max is slightly different in that we're starting at 4, 5, 6, 10, 11, 12, 16, 17, 18, 22, 23, 24. Reason being, we're in what we call steady state around those times. So minute 4, we're going to do this. Relative to VO2 max is pretty easy. We're going to type in equals. We'll come on over to VO2. There we go. Divided by this person's max times 100. And before I hit return or enter, I'm going to actually come up to the formula. And I always want it to point to this VO2 max. And to do that, we'll have to add in front of both the row and the column G, we'll add a $sign, just $1 sign in front of G, and $1 sign in front of the 11. That says, hey, Excel, keep pointing to this cell. We can hit return now, and this tells us the relative to VO2 max this person was at. Drag that down. What's cool is, again, it's always pointing towards the VO2 max, which is what we want. And it points on the same row, VO2. Cool. And before I keep moving forward, I'm going to do the mechanical efficiency. Let's go back. Mechanical efficiency, slightly interesting in that we have one thing happened before that. We need the energy required, which is work rate in watts divided by 69.78 watts per 1 kcal per minute. So mechanical efficiency, how we've defined it, is the energy required divided by the energy that was used in that minute times 100. And energy required is always going to be is always going to be less than energy used. Energy used is always going to be more than the energy required. We're not 100% efficient. So pushing on, we have equals to parentheses. Let's figure out the energy required first. I'm going to come on over watts and divide that by 69.78. Close one parenthesis and then divide that by, and come back over again, the energy expenditure, exact energy expenditure, close parenthesis, times 100. All right, that's a number I would expect, about 12 or so. Not 100%, nothing like that. And since we're only using 4, 5, 6, 10, 11, 12, I can just skip the next 3. Or actually, I'm going to zoom out so it's easier to see. Okay. One more. There we go. So copy, paste, and lastly. So we're only using the times where we were in what we would call a steady state. So we were about 24, 29, 30, 36, and 44, 45% VO2. Okay, cool. What's interesting though is we also see our mechanical efficiency starts off around an average of about 12.94. Then the next stage, 15.78. Then about 17.31. And 17.11. So we might have peaked or maybe even started going down a little bit nearing here, and we're only at about 45-ish. Let's see, 45 basically on the dot percent of VO2 max, 35.6, and so on. So that's just something interesting about the data you can see. Then you'll also compare this to the treadmill or vice versa. See, at the same work rate, as close as we can get, as close as we can match, how did the mechanical efficiency track? Did it change? What happened? So that'll be up for you to look at your data and see you can transfer this stuff on over. One other nice thing is when you're going to do this to your other data sheet, once you've done this, you have everything pointing to things. As long as you put the VO2 max in the exact same column and row, as long as you put that there, you can just copy and paste this, making sure you paste this stuff to the correct, starting from the correct row and column. In this case for me it would be highlight or putting my cursor or this on F26. It will auto-populate all of this stuff. You only have to do it once, which is nice. We like doing that. We don't want to have to do things multiple times, right? So as long as you do that, everything will work out just fine. If anything looks a little wonky, of course ask. Of course ask. We want you to get good data. We don't want you to get any bad data. Otherwise, that'll about wrap this one up. If you do have any questions, please feel free to shoot me an email or your instructor an email, or ask us in class, or come to office hours. And I will see you in the next one.